Hello everyone, this is Madhu Sirikonda of Mechanical Engineering Department from St. Peter's Engineering College, and I have uh, completed my MTech from one of the JNTU affiliated colleges in thermal specialization, thermal engineering specialization, and BTech in Mechanical Engineering from KITS Warangal, and I have completed my schooling from Jawahar Navodaya Vidyalayas, Nizamabad, and the subject that I am going to explain in the lectures is mechanics of solids. Mechanics of solids. The mechanics of solids is a design subject. It is a very important and basic subject for the graduates, mechanical engineering graduates, as well as civil engineering students, because it is the basic subject which deal with design criteria and the fundamentals of strengths of different materials, how to calculate the strengths, how to calculate stress, strain uh, under different conditions. So this is a very important subject, and it is derived from this engineering mechanics. It is derived from mechanics. It is not engineering mechanics. From mechanics, it is divided. Mechanics is of different types: the mechanics of rigid bodies, mechanics of deformable bodies. Mechanics of rigid bodies, again, it is categorized into two types: statics and dynamics, where we deal with we study with the forces that are acting over the body. We don't discuss about what effect that is taking place because of that applied force on that body, what internal changes are taking place in the body. In mechanics of solids or mechanics of deformable bodies, the subject name has got different names. The subject has got different names. So mechanics of solids, mechanics of deformable bodies, strength of materials. So this subject deal with the mechanics of deformable bodies, and it deal with the non-rigid bodies, how the internal changes, internal resistances are taking place while the forces are applied. Different types of forces: point load, UDL, uniformly distributed load, or different varieties of loads when they are subjected to when the beams. You will find the beams also. So when we enter into the introduction to the subject, we will discuss. When we see the syllabus uh, or the topics, there we can find out what is different topics that are present in mechanics of solids or strength of materials. Now, when we see the introduction to the mechanics, it's a branch of physical science that deal with the state of rest or the state of motion of the bodies is termed as mechanics. The state of rest or the state of motion of bodies is termed as a mechanics, and the classification of mechanics goes like this. Based on the motion, it is divided into two types: statics and dynamics. And the statics deals with the study of the forces of a bodies which are at rest, static, the bodies which are at rest. And dynamics deals with the bodies which are in motion, the study of forces of the bodies which are in motion. Here, it is divided into statics and dynamics, and dynamics still divided into kinetics and kinematics. So kinetics deals with study of motion without considering its cause, while the kinetics is the study of motion with taking forces into consideration. It means the kinetics deals with uh, the body forces. It also consider the body forces. Kinematics won't consider the body forces which are influencing on it. Based on the state of objects, mechanics of non-deformable bodies, or they are called as rigid bodies, and mechanics of deformable bodies. Now, mechanics of non-deformable bodies we have already studied in, generally we study in engineering first year, engineering mechanics, that is the mechanics of rigid bodies. And in mechanics of deformable bodies, this is what is our subject now. So it is solid mechanics or strength of materials. The bodies which are not deformable, they are rigid bodies. The bodies whose internal structure, internal strength will vary depending upon the application of the force. They are called as deformable bodies. So for deformable bodies, the subject we named it as the strength of materials. The main objective, here it is given, the principal objective of mechanics of materials is to determine stresses, strains, displacements in structures and their components due to loads acting them. It majorly deals with stresses and strains, especially what are the stresses that are induced in the bodies, what are the effects that took place because of on the application of the load, how the dimensions are getting changed, even if we apply the load, to what extent we should apply the load such that the body will not get permanent deformation. There are some elastic limits and plastic deformation limits when the body is subjected to a force, and that force is within that elastic limit. If the stresses induced in the body within the elastic limit, the body can regain its original strength on removal of the load. But if you keep on increasing the load, the body will be subjected to the plastic deformation, and their yield points will come under, and there what happens, the body will be completely getting deformed. So especially it deals with stresses and strains and displacements in structures and their components due to loads. Displacements in structures means bending moments. For example, in bending moments, we can find out how much that point, the application of the load, how much distance it got moved, that member got moved because of the application of the load, where the body is at a static position, still the loads are acting on the body. Apart from the reaction forces, if any external forces are acting on the body or due to its self weight, the body is subjected to the bending, and we will find the uh, dislocation or the movement in the body, or just all the particles or a few critical particles may change the position from one point to the other point. So the subject, it also deals with the displacements in structures and their components. due to the loads which are acting on them. Now, here we have one more point, that is mechanics of fluids is speaking about. In engineering problems, we usually encounter with fluids. The air we breathe is also a fluid. What is a fluid? What is a fluid? Fluid, in simple words, an object which has got that flowability. It has got a property of flowing property. Any body which has got the flowing property. Water is a fluid. Or any object you take which is under liquid state, or the distance between the atoms or intermolecular distance is very high. As the distance goes on increasing, the intermolecular distance goes on increasing, we will find the nature of fluidity will goes on increasing. For solids, the intermolecular distance is less. The atoms, they are held together, it will be tight, and it will give a proper shape. It will get a proper shape because of that intermolecular attractions or bonds. Now, if that intermolecular distance goes on increasing, after a certain limit, it will gain a property of flowability. It will lose its property of rigidity. The rigid property, it will lose its rigid property, and it will get the flowing property. If that intermolecular distance goes on increasing, then we call that substance as a gas. It will become a gas. So gas is also one of the fluids. The vapor form of an object is a fluid. Water, if we take water, H2O. H2O is a substance, a pure substance. If we consider pure H2O, it will be at 1 atmospheric pressure, at 0.01 degree Celsius. The state of the H2O is ice, solid. It is ice. We call it as ice. But the temperature goes on increasing at 1 atmospheric pressure. If the temperature goes on increasing, it will be in the form of liquid. Just because 0.01 is the triple point temperature. Once you increase the temperature, you will get the state being a liquid state. The intermolecular distance we are increasing because we are increasing the internal energy of that particular substance. It will be a liquid, and then if it goes on increasing, that will be a vapor. So what they are speaking here, it is in engineering problems we usually encounter with fluids. Definitely, the air we breathe is also a fluid. Yes, the water which we are using for all purposes is also a fluid. The study of motion of fluids plays an important role in engineering problems. The study of motion of the motion and forces on the fluids is termed as fluid mechanics. The study of motion and forces on the fluids is termed as fluid mechanics. If we study the forces and the internal stresses and strains that are developed because of their nature, rigid nature, so it is solid mechanics. Here, study of forces and its motion, like we discuss about pressure, viscosity, some other factors. So that will be in fluid mechanics. There we get how the flows are getting distinguished depending on Reynolds number. It can be a turbulent flow, laminar flow, or transition, or in transition zone. So that is fluid mechanics. It is a separate topic, and the subject entering into our subject, that is solid mechanics or mechanics of solids, or strength of materials, or mechanics of deformable bodies. So it's all same. Generally, we discuss about the stress. What do you mean by stress? Stress is the you are having a we'll have an explanation for that. If you are having a body, that body is subjected to force. When a body is subjected to some force, it can be a pulling force or pushing force, a pulling force or a pushing force. When a body is subjected to some application of the loads or a force, internal resistance will develop. Internally, we will find some development in the uh, resistances. Just example, if we are attacked by some microorganisms, the resistance for the resistance of our body, that is immunity, especially the white blood cells, platelets, etc., will attack on the microbes or the virus. In the same way, if you are having a body, on that body I am applying some load. So internally, you will find some stress to withstand that load in order to not to get the body deformed. You are struggling to either to bear that load or to push it out. For bearing that load, you are doing some work. Internally, you are doing some work. You are getting some stresses. We call it as stresses. Some resistance forces are developed in the body, and we call it as stresses. And that we see here as if we put our all these general things in a proper way, we get some terms here. Stress, it is given by the force of resistance offered by a body against the deformation is called stress. Whatever we discussed is same. The force of resistance, the resistance force offered by a body against the deformation is called as the stress. And here one example is given. You are having a cylindrical rod of length L. You are having a cylindrical rod of length L. When it is subjected to two pulling forces on both the ends, you have pulling forces towards left and right. Because of this pulling force, you will find small change in the dimension of this length, dimension of the rod, that is length. See, the length will increase or the diameter may decrease. So whatever here it is shown, L plus del, and the diameter got changed from capital D to small d. So such type of changes do occur when the forces are acting on the body. Now, how do we calculate the stress? A general formula. Again, we are having the different types of stresses and strains. Here, the general formula for stress, it is sigma equal to P by A. P is the resistance force. How much resistance force is exerting it in the body? If P is acting, the resistance force will be P only. So, P by A. So it is before deformation, the body will not get deformed. The stress acting on the in the body is P by A. P is expressed in newtons. A is original area in square meters, meter square. Again, we have different units and their conversions for stress. A Pascal. No unit, it is a Pascal. For stress, we can use Pascal as one of the units for the stress. We can also use this Pascal as a unit for pressure also. There it is different. Pressure, the mathematical relation may be same, units may be same, but the difference is pressure is the normal force acting on the body. Stress is the resistance force developed in the body. It is because of the resistance forces developed within the body on the application of external loads, and that is resistance force per the area, and the pressure is the normal force that is acting on the body, normal force per area. So that is the difference. So as Pascal is a small quantity in particle, multiples of this is used. So this unit is used. It is 1 kilopascal, say 10 power 3 Pascal or 10 power 3 Newton per meter square. And it is kilopascal. So megapascal, it is 10 power 6 Pascal, 10 power 6 Newton per meter square. Or if we convert this meters into mm, it is 10 power minus 6. It should get usually it should get multiplied with this 10 power 6 and 10 power minus 6 will get cancelled, and it will be 1 Newton per mm square. So megapascal, this is kilopascal, megapascal, gigapascal. Gigapascal means 10 power 9 Pascal, and it is 10 power 9 Newton per meter square. So this is what is stress. Now the strain is it is the ratio of change in dimension to its original dimension. Strain. See, on the application of this load, we got some change in a dimension, that is length. We call it as longitudinal strain, and perpendicular to the application or the load direction. If you find the changes in the dimensions, that is lateral strain. Now coming to strain, we have a formula. It is change in dimension by original dimension. Simple. Just we go through a simple notation, that is del divided by original length is actually it is L. So del by L. So there is no units. It is a dimensionless quantity, that is strain.